Hi guys, Igor again. Today we'll test index and reverse index performance in Postgres. So let's start. To speed up the process and show examples, I prepared the database. So we have Dockerized Postgres. And let's see what we have here. So Docker PS. Let's get into the Postgres like that. And we have account table. Maybe let's show the schema. Oh, something wrong. And we have about 15 million records, if I recall correctly. Yeah, and I prepared the script, Node.js script to insert them if you want. It's all my GitHub repo, nothing fancy here. We just use the page library to talk with the Postgres, and we insert some random 50 million records here. So to run it, you just go to the folder and to note that, and in batches it inserts the data, and you probably need to wait a few minutes to insert it all. We'll just insert the one batch to see that it works. Okay, and we should have more records. Yeah, we have about 15, almost 60 million. 16 million is enough. Okay, guys. So one thing to note with the script that I on purpose limited the resources that Postgres have to make it more reliable across various machines and to show the performance gain better because of 1 GB of RAM and 1 CPU. If you insert the data, it's probably worth commenting it. Okay, but let's see actually how much indexes can speed up our queries on database like that. So let's take a few records from this table. Okay, and let's see what kind of indexes we have. We have index on primary key, obviously, ID, and attributes, which is JSON, and then we have inverted index. We'll get there in a while. So let's turn on the timing, and let's select an account by ID, which has an index, obviously. It's a primary key. Let's go with that. Okay, and as you can see, it's blazingly fast, less than millisecond. Okay, we don't have an index on name, so let's see how much time do we need to access the name actually. So like that, name. It should take a few seconds. Yeah, as it did. 4 seconds. Okay, 4 seconds. 2.5, almost 3. Let's say that's something in between 2.5 and 3. And let's right now create an index on the name, and will also take a while because of our database size. Maybe before that, let's see what's the size of our database. I think it was something like that. Yeah, so as you can see, 1.6 gigabytes. So it was also worth limiting the size of RAM that database has access to, because then with more RAM, as I have 32 on my machine, it it can load it on to the RAM. So probably all queries would be faster. But never mind. Let's create an index, account name, account name. Let's wait. We are creating p3 index right now. Yeah, we have it. So as you can see, it took 76 seconds over all. But let's see the performance difference. It was, as we remember, between 2.5 and 3 seconds. And right now, as you can see, it's like 30 milliseconds. So we get 1000 performance improvement actually from 3 seconds to actually more. We went from 3 seconds, let's simplify, which is 3000 milliseconds, to 1/3 of the millisecond. So it's like 10,000 times faster. And obviously it will grow. The improvement will be more the more data we have in the table, because sequential scan without the index, it grows linearly as the size of the table grows, and performance of the index it grows logarithmically, its complexity as the size grows. Okay guys, but let's see, let's talk about attributes. So what I did here with in the attributes, we have a JSON which has the same exact data as regular name and country code field, but in this attribute field, and we'll see how much performance improvement the GIN, which is Generalized Inverted Index, can give us. And to simplify, it is an index where you can index composite types like arrays, documents for full text search, and JSON documents as we have here, and query one of its fields or all fields at once. So first, we do have an index as shown here, but we can show how the query would behave without the index by using this syntax, because we can do something like that, and it basically takes name attribute from the JSON field, but doesn't use the index, because to use the index, GIN index, we need to use different operators. So let's check the performance of this query. Yeah, and it's like 5 seconds a lot. Maybe 4, actually slower than sequential scan for just the name field. And to use an index with the JSON, we need to use the different syntax, which is this operator, and here we need to write a JSON that should match with our data. So basically it is something like that, meaning that we search for all JSON documents that have this field with this value match, and GIN index will be used. And as you can see, it's always fast. It's not as fast as p2 index because of the implementation details, but still we went from like 4 seconds. Yeah, 4 seconds, I believe. Yeah, 4, almost 5 to like 2 milliseconds, right? Which is not as good improvement, order of magnitude less improvement comparing to the p2 index, but it is still over 1000 times faster. yeah, I think that's it. The details I will actually explain in the blog post that I'm working on, so stay tuned for that. And yeah, thanks for watching. Like the video, subscribe to the channel, and stay awesome. I see you in the next one. See ya.